So if you're molding with a silicone in those applications, usually it doesn't matter because you'll be putting more on later anyways.
Right.
If you have an automotive part where it has to be painted, or you have a plastic part that has to be painted, again, it depends on how the molder is set up, how the manufacturer the plant.
Hello.
And most of the paint shops do clean before they spray paint. Waxes tend to be harder to take off than a silicone.
Okay.
So there's a lot of variables running through this. The wax is harder to get off. The silicone tends to be easier to get off.
Yeah. Point.
So if you do have a cleaning operation, that's one of the issues.
Yeah.
The fluorocarbons, again, don't tend to transfer, so that doesn't tend to be a problem.
Okay, I got it. And also I found because we talked about this and Dow and Blue Star, Momentum, Wacker even, they haven't really changed their portfolio for many years because they do not see there's a big need to change the chemistry or adjust the chemistry.
That's right.
In general, do you see that this market really change the game, or something very different, or in general you think molders are quite happy with what they have?
Molders are never very seldom happy with what they have. One of the I guess one of the issues is that the resins are constantly changing, and slight changes in the curatives or slight changes in the part can require an entirely different release agent formulation, and a lot of that has to do with the shape of the part.
Mm-hmm.
And what the mold has to look like, because if you've got very very slight draft on it, where most molded parts are not perfectly square.
Yeah.
Or there's very few perfectly flat surfaces because it's tough to get something.
Yeah. But do you think this type of problem can be solved by changing the chemistry, the fundamental structure or chemistry of the resin or the functional silicone? I mean, I guess my question is really, believe one resin will solve all the problems, or with these new programs, there's maybe a need for new types of resin which performs better, or new types of functional silicone like amino silicone which can perform better.
Yeah, this is where the small formulator comes in, because if a molder is being asked to make a part which has been designed by an engineering department,
mm-hmm.
and it just isn't coming out of the mold properly, they may need a mold release agent with a little bit higher slip value so that it comes out.
Okay.
And you don't know until you try to manufacture the part in that mold.
Okay.
And the mold design, because of the part design, is constantly changing. And one release agent that worked phenomenally in same polymer system in a different part design
Mm-hmm.
all of a sudden no longer works.
Right.
So
Yeah.
the specialty mold release supplier for that manufacturer is constantly being called in to tweak the products.
Yeah, but I wonder, my question is more like moving a little bit further up to the value chain. Is there a
Okay.
need for the chemical manufacturer like Dow or Blue Star or to design a more efficient resin or more efficient amino silicone? Or you think you've been working on that? I think you probably spend a lot of time trying to identify the best performing ones. But with the change in the industry, do you see there's a need for a new generation of chemistry?
My feeling is that there's always the need because it's constantly changing.
Mm-hmm.
The major silicone companies have much bigger opportunities than trying to design different external release agents. That's not what they spend their R&D time on.
No.
And one of the things that's, and let's just talk about silicones because I can
Mm-hmm.
use that as the example, but the same thing has happened with fluorocarbons and waxes.
Right. Yeah.
The end users of the wax products, the end users of fluorocarbon.
Hello? Hello?
Know how to use the products.
Sorry, Wallace, I couldn't hear you. I mean, I think the signal was not so well.
Is this any better?
Oh, yes, now it's better. Yeah.
Okay. On my cell phone, every now and then, my cheek hits the wrong button.
Yeah.
The end user over the years have become very well-informed, sophisticated end users.
Yeah.
They know more about the use of silicones or fluorocarbons or waxes than any of the raw material suppliers.
Okay.
And the R&D groups within the major silicone companies
Mm-hmm.
have not developed the expertise on how to use them
Right.
anywhere near the same level as the end users do.
Yeah.
Now, they can't travel all over the United States or the world talking to the end users to try to understand what the issues are.
Yeah.
That's where the second tier comes in.
Oh, okay.
They're regional, they're specialized, they tend to know the companies that are using the products, and they talk to the guys out on the line that really know how to use these things.
Yeah.
And it's amazing the expertise level that is at the manufacturing level rather than the raw material supplier level.
Right.
So that's evolved over the last probably 20 years to the point where Dow Corning has very little end-use application R&D structure. I mean, even before they were shifted over to Dow.
Mm-hmm.
That was severely cut because
Yeah.
there was no need for it.
Okay. But the second tier solution, silicone producers, they don't have the do they have the expertise, capability to develop new structure, new chemistry?
Very little.
Very little.
I mean, companies like ICM, as an example, they have some application testing,
Mm-hmm.
but they tend